I've got a Marshall here today. It's not rocking the way it should. Not good. Long story short, plug it in. Very, very, very low output. Almost like there's no gain stages there in certain points and it's just bleeding over into the other parts of the circuit to come out. It's happening on all channels and the like, so we need to get this apart and figure out what the problem is. Hopefully it's something simple, maybe just a bad tube somewhere in the shared parts of the circuit. But if not, well, then we've got to dive a little bit further and find what the problem is. Enough talking, let's crack it open. When we gave this the initial test, we found that no matter what the channel was on, volume was low. So that says to me that most likely the problem is going to be after the master volumes. What's after the master volumes? The effects loop, and of course the phase inverter. So right now we're feeding it a 1K signal, which should, if we turn it on, give us volume, but that is so low. There is next to nothing coming out of there. That's running on high power. That's probably at about third volume. And in the most literal sense, you can barely hear the faintest little bit in the background. Just, it's almost like tinnitus after you go to a concert and you don't wear earplugs. So the first thing I'm going to do, just to get some basic ones out of the way, is I'm going to replace the phase inverter tube and replace the tube prior to that, because I'm not sure if that's in the circuit after everything. Might be, might not be. We'll go through, we'll just change those because it only takes a couple of seconds to do it and it might solve the problem. If it does, excellent. If it doesn't, well, then we can start digging a little bit deeper. Well, we've done the good old swap-a-roo of all the preamp tubes and the likes to see whether that cured our ills, and it did not. Now we're currently measuring the output of the amp and it looks horrid. That is a terrible looking wave. It's incredibly choked off. That's in the order of peak to peak 200 millivolts. The amp's at a third volume. That should be much, much, much higher. So means we're going to have to jump inside the amp and start measuring voltages, probing circuits, and getting into the real nitty-gritty of it. Okay, time for the tools out. On the bench we go. Now we get to do all the fun stuff, such as probing voltages and finding out exactly where the problem might lie. First rule of all of this kind of stuff is, test thy voltages and make sure they're all hunky-dory, because if they're not, well, you're not going to be able to get much further than that if you haven't got the proper power supply going on. Just get a good old ground connection going on there. And we want to make sure that each of our pins and all the rest of that, and valves and tubes and whatever you want to call them, have the correct voltages going on. 300 volts, 300 volts. That seems a little bit low for an amp such as this. It's on high mode. Those tubes should be running closer to about 500. Yes. So, let's try again. Come on, here we go. Give me a proper connection. Yeah, they are running very, very low. 318 volts on the plates of the output tubes, and that should be more like 500. So there might be something going wrong with the tubes there. I'll have to check. I might have to throw in a set of tubes and see what's going on, because they're just straight to ground and all that. Let's see what the center tap has to say then. It should be brown, just no, red, which goes all the way down to there. Cool. Yep. 150. 150. That's not right. That is not right at all. Oh, it's because I was going to the wrong thing. Doing well. I am doing well today. Let's get right inside there. Yeah, so we're only getting 320 from the first node. That should be much higher. I think there might be something wrong there. Let's delve a little bit deeper. So now that we've found out that there is low voltage going on, Of course, it was something that's relatively simple that's kind of come up. If we look, just move that little cable out of the way there. You see that there's a, no, let's try that way. There we go. If we look behind that yellow cable, see the white one, there's a fuse hidden there. That fuse didn't just go, it went with a bang. So something shorted out there. Question is, which part of the circuit is that feeding? That looks to be, what is it? 630 milliamps at 250 volts, so that's going to be the high tension fuse. So what has caused this fuse to blow? They don't just blow spontaneously. There's quite possibly a tube that's gone short, could be one of the caps has gone bad somewhere, unknown. Let's start by eliminating the tubes first, by pulling them out, powering it up, and seeing whether anything goes bad. First, we need to put a new fuse in there so we can at least test it. Well, in my wonderful late afternoon state, pulled the power tubes, put in a new fuse, went to go power it up on the variac, forgot to turn the variac to 0. End result, bang, one fuse gone thermonuclear. Good old big old bright flash. There's no tubes in there at the moment, so what that's telling me is that there is a high probability we've got a shorted cap somewhere along the lines there. It's just pulling way too much current and is bad, which means this repair is going to be a bit on the pricey side. If we're going to do it, we're going to do it properly. We're going to replace all the caps in the high voltage supply with proper brand name caps. See if we can get them 105C rated, because then they're going to last as long as they possibly can. But first things first, I've got to contact the customer and let him know the less than stellar news. See if he wants to go ahead with it. If he doesn't, well, we did our part and send it on his merry way. Alternatively, it's just going to be something that maybe he'll sell off to someone else who wants to bother dealing with it, because he only bought it secondhand very recently. It worked, and then it kind of stopped working. It's just the luck of the draw when you buy secondhand stuff. It's not to say the person who sold it to him ripped him off, because it worked when he bought it. He took it home, played it a little bit, and it stopped working. Spontaneous failure is a thing that just, it happens from time to time, especially in amps like these. The cut price versions of older Marshalls or other circuits that are made to a price point, they're not going to last as long. When you can cut 10 cents, 10 cents, a dollar, 10 cents from each component, and you're making 1,000 of these things a month, that adds up a lot in a year. So of course they're going to cut every little tiny bit that they can. That's what makes a difference between something that's really good value for the money and something that's just straight up good. But the flip side of that as well, you could not get an amp like this at this price 20 years ago. It just wasn't going to happen. Nowadays, you can get stuff that's really cool like this. It's just not going to last. Let's see what the customer wants to do, and we'll continue on from there.
All right. It's been a week and a bit. Now we're back into the amp. Got the go-ahead from the customer to replace the caps, which is a good thing. It's going to make this a much more reliable amp, and I am, of course, on the tail end of a head cold as well. Hence the reason I probably sound a little bit different. Now that we've got us some shiny new caps in there, went for the best we could. Problem is with this amp is that it uses very, very tightly packed caps, and there is no space between here and the PCB, so they have to be little short squat ones. Normally we'd use a range of niche cons and all that kind of stuff to go in there. Good quality 105C rated jobbies, but the problem is that caps like these ones here, which are really, really good quality and the right values, are also too tall. That meant that we had to go searching and scouring using parametric search across every supplier to try and find good quality caps that would actually fit this height, these values, this exact footprint. So we ended up with some good quality niche cons across the board for the 22s and the 47s. In the case of the 220s, we ended up Rubicon, also a good quality cap. And then, of course, we've got ourselves some Cornell Dubelier? I don't know, CDE, parent company of IC, in the 330 at 350 volts. So they were actually originally 315. We bumped it up to 350 because, well, that's what was available, fit the footprint, and what's an extra 70 odd volts on there that they can handle? That's a good thing. So what we want to do now is we want to power it up on the Variac and check for current draw. See there's no other shorts and the likes. Check the voltages to make sure they're sitting where they need to be. Last time when I did it, I had the Variac turned to on, and it should have really been into the 0 position. I'm not going to make that mistake again. So we're on 0 here. Yeah, so all the fuses are the right value. If we power it up slowly and we see that there's excess current coming through, that would indicate that there's still a short, but I couldn't imagine what would be shorting. There's currently no tubes in there. All the resistors test okay. So a bunch of shiny new caps, it should do the job, because that was only happening as well on the low power side. So it was blowing the fuse on that low power, because what this amp does in order to get high power, low power, is it's got 2 separate voltage rails for high power and low power for the output tubes. The high power one is higher voltage, therefore high voltage, more swing, more output volume. In the case of the low power one, it drops that voltage down. So it uses another tap actually on the power transformer. It's a really good way of doing it. It's much preferred to some of the others out there. It's going to give you that saturation that you need from a power amp stage in a Marshall. So let's fire it up and see what happens. Awesome. We've got bias voltages. We've got voltages on the plates of the tubes. Now, let's get some tubes in there piece by piece and power it up and see, make sure that we don't have any tube shorts or anything else like that. We'll start with the preamp tubes, because they're further along the node, and then just keep adding them in, powering it up, checking it, just to make sure there's nothing going real funky there. Onward and upward. Now that we've got the amp all hooked up, power tubes in, into a dummy load, signal gen attached. Let's get some power to it and see. So feeding just standard old 1K into this, get a bit of volume there. Volume there, really? That one, there. Cool. Yep, that's pretty damn happy. So that's a lot better than what it was before. What it was before was an absolute just nightmare. There's no output, things were super low, because that fuse blew. That fuse gone as a result of caps going bad. They went short, too much current, boom, bye-bye. So that's a pretty good looking wave for a clean channel on a Marshall that's not exactly designed for clean. Obviously we can clean it right up by feeding it right down like that, but where's the fun in that? We don't want that. We want a little bit of character. Put it over to crunch mode. Bam. Got our inversion on there, which is nice. Yep. EQ knob's doing what they need to. It's not going to tell you a huge amount there, but the fact that I can turn these and see little bits of changes. We've also not seeing any scratches or random fuzz and marks coming along is a nice thing. Yep, presence control, resonance control. Barely does anything on this type of thing. Tone shift. Yep. Nice. Let's go over to Flavortown on the gain channel. Classic gain. Yep. Gain works there, does what it needs to. Volume up, volume down. Overdrive 2. Nice. Awesome. Go to master 2. Yep. Whoa, can hear that. Loop, of course, can switch on and off. This is a much, much happier amp. Let's check the low output. Stand by. I'll go into the clean channel again. We've got a low. There we go. So that's now at half volume. Well, halfway up on that. So this is the clean channel, clean mode, straight up, halfway. Nothing much fancy going on there. And then of course we could switch it over to high gain, high volume. You can see an increase in there. So what, 3.8 volt RMS, going down to 1.8 RMS. So we're losing a fair bit of volume there. Isn't enough to really make a huge noticeable difference? A little bit, not greatly. You know, if that was even lower, cool, then we could actually push this like much, much harder. But it still goes like the clap, basically. Let's say we plug it into a speaker load and get a bit of a test that way. Excuse the noise. Our shop here is very, very bad when it comes to RF interference. Got terrible lights in here. There's a lot of businesses nearby, so there's a lot of just awful noise in here. So you're gonna hear buzz, you're gonna hear hum, but such is life. It's the way it is. So let's take a listen first to a bit of clean stuff. So that's with the controls pretty well, just straight up at noon. Nothing fancy going on. Master, that's also up at about sort of half volume as well, just running through a 112 cab here.
was how we managed to fix that Marshall. Here we are back, of course, on the bench, and you may notice this isn't that Marshall, because smart old-fashioned me managed to not shoot an outro when the amp was still here. That's long gone and gone back off to its customer. Instead, what we've got is a bit of a preview for one of the other amps that's coming up in the repair series. This is an SLO100 that unfortunately another tech has kind of, not done the work that you really want on an amp like this. So we're going through and fixing up what they missed, what they bodged, and going to make it into a proper fire-breathing monster again, just like an SLO should be. So, until then, if you could like and subscribe and comment and ask questions and do all that kind of stuff, that would be absolutely smashing of yous. Because the more people and the more interactions we get, and the more people who watch, the more we'll do, and the more I can actually dedicate to doing sort of this stuff. So until the next time, we'll catch you.